Let's look at how to evaluate and graph piecewise functions. For piecewise functions, we have restricted domains, and we want to see what section of our function applies to the value that we have. As an example, right here we're saying that x is -4. Remember, normally it's f of x. So again, we're saying that x is -4. Were we to put -4 here and ask, is -4 greater than or equal to 1? Is that true? No. -4 is actually supposed to be less than 1. So this third function is not something that we would use when we look at -4. So we move on to the next part. Is -4 between 1 and -2? We know that it isn't, so we're not going to use this second function either. So we're not using that. So far we know that for -4 we won't use either of these functions. So were we to replace -4 with x here, is it true that -4 is less than -2? Yes, it is. So we will use this function to evaluate f of -4. So for our piecewise function, f of -4 is defined for the function -3x subtract 10. And of course, x is -4 in this example. So -3 times -4 is going to be a +12. And we need to subtract 10 from that. So this is going to give us 2. So f of -4 is 2. So how about the next one? We're saying here that x is -2. Which of these three categories would that fall into? We know that -2 is not greater than 1, and so we would not use this function. We know that -2 is not less than -2. This does not make sense. -2 is not less than 2, so we wouldn't use this one either. But we do know that this would work, because if we put -2 here, first of all, -2 is less than 1, and also because we have the or equal to, -2 is less than or equal to -2 because they're equal. So this is the function that we would use to evaluate -2. So we would say negative x plus 1, but for x we're using -2. So it will be -2 plus 1 squared plus 3. -2 plus 1 is -1. So we're doing negative of -1 squared plus 3. -1 squared, or -1 times -1, is a +1. We still have the plus 3, and we still had this negative here. So when we add -1 plus 3, we end up with 2. So we have 2. For our last value, for 5 halves is about 2.5. So which of these three categories would make sense for 2.5? We know that 2.5 is not less than -2, so this first category doesn't work. We know that 2.5 is not less than 1, so this doesn't work either. We do know that 2.5 is greater than or equal to 1, So this is what we're going to use. So we have the floor function that we're going to apply here. So we're going to take 1/2 and multiply it by the x value, which we remember we said that that was 5/2. So 1/2 times 5/2, and of course we have to subtract 2 at the end. That's what the function says. 1/2 times 5/2 is 5/4. So 1 times 5 is 5. And 2 times 2 is 4. We still need to take the floor of that. So remember, 5/4 is basically about 1.25. So the floor function goes down to the next, goes down one value. So if we're at 1.25 and we go down to the lowest value, it'll be 1. So the floor of 5/4 or 1.25 is 1. If you're having trouble with the floor function, I have a separate video on floor and ceiling functions that you can take a look at. So it'll be 1 minus 2, which would be -1. Let's graph this function. So first, what we're going to do is we're going to use the values that we have here to split our graph. So we're going to put negative, remember we have -2 and -1, so we're going to split our domain. So we're going to draw a vertical line through -2, and another one through 1. For our first graph, this would be everything to the left of -2 because it says x is less than -2. We can substitute values on this side of the graph. For example, -3 is on that side of the graph. So if we wanted to, we could do -3 times some value of x, subtract 10. That's what the function says. But remember, we're substituting -3. We're trying -3 because it's on that side. So -3 times -3 is a +9. Subtract 10. 9 minus 10 is -1. So what we said just now, what we worked out just now is if we input a -3, we get back a -1. So -3, -1 is here. The function -3x, which is what we have over on this side, -3x minus 10 has a slope of -3. The slope of -3 is the same as -3 over 1. This tells us that we can go down 3 and right 1, or we can go up 3 and left 1. So if we applied this pattern, the points would go as follows. From this point that we put here, up 3 and to the right 1, up 3 to the right 1, up 3 to the right 1, and then if we continued, we'd go down 3 and to the right 1. However, when we put that last point, it's right on -2. Look at what's happening here. At -2, the inequality sign does not have an or equals. So what we can say is that whatever value we have here is not included for that function. So we're going to put an open circle on that particular point, and let's just connect everything up. For the next function, which is between -2 and 1, this is what we have. Our function here is in vertex form. For vertex form, which is a times x minus h squared plus k, we know that h and k represent the vertex. So in the case of what we have here, our vertex for this parabola would have to be -1 and 3 as the vertex. So -1 and 3 would be here. The fact that we have a negative sign here tells us that the parabola is going to be facing down, so we expect that it's going to face down. If we evaluated at -2, we would have the negative of -2 plus 1 squared plus 3. This would give us the negative of -1 squared plus 3, and this would be the negative of 1 plus 3, which is equal to 2. So in other words, when we input -2, we got back 2. So that point would be here. Notice I put a solid point this time because, again, we were working it out here at 2, and look at the inequality sign. It has that or equal to underneath it, so that tells us that we can do a solid point there. So let's see what would happen if we were to evaluate this function in the other location, which is at that 1. So if we input 1, we have the negative of 1 plus 1 squared plus 3. 1 plus 1 is 2. 2 squared is 4. So we're going to have -4 plus 3. This is equal to -1. So for our output, in other words, if we input 1, we're going to output -1. So at 1, we would have -1. And that point would be here. However, notice that right here, that the inequality sign does not have the or equal to underneath it. So we're going to put an open circle at that particular location. Now let's evaluate the last part, which is going to include our step function. And this is the part that's to the right of 1. So we know that the step function is going to look something like this. We know that the 1/2 is going to cause a horizontal stretch by a factor of 2. If it were 1/3, it would be a horizontal stretch by a factor of 3, and 1/4 would be a horizontal stretch by a factor of 4. So if we applied everything, then we're going to end up with basically stairs that are the size of what the denominator are. So if the denominator is 2, then it will be 2 units across. If the denominator is 3, then it will be 3 units across on each step, and so on. So if we were to evaluate this step function or this floor function at, let's say, +1, we would have 1/2 times 1 then subtract 2. So 1/2 times 1 is 1/2. And if we do the floor of that, then that would be 0. And 0 subtract 2 is -2. So in other words, when we input 1, we get back -2. So 1, -2 is here. If we continue applying the step function, we're going to end up with the following graph.